So what is a Hackerling anyhow? This is a Hackerling circuit. How did I make it? What's it for? Let's explore together and find out. There are a number of parts that make up a Hackerling. The first two are these integrated circuits labeled IC1 and IC2. You see me prepping them for placement on the board, and then I will be soldering them in. In this video, I'm showing you the highlights of the build process so that you can get an idea of the things that a Hacker Scout will be doing on their first project, but this video does not take the place of the others that go in depth into each part, the purpose, how it works, as well as the skills that must be acquired, for example soldering, in order to become a fully fledged hacker. You may have noticed that the soldering tip I just selected looks sort of like a small flat blade screwdriver. The width of the blade of the tip is the same as the width of the copper pads that are being soldered to. Choosing the right tool, temperature, type of solder and flux, as well as the techniques you use will be greatly expanded upon in the future as you go through the tutorial videos. Believe me, you will learn this all, and very quickly I might add. If you look closely at the bottom center of the screen below where I am soldering in the ICs, you will see the accelerometer already assembled on the board. These are tiny surface mount components, and while learning to solder these tiny parts effectively is part of the mastery level of soldering required to get the soldering badge, in the case of the Hackerling circuit, those parts will come pre-assembled for you by one of the mentors. I'll take a moment here to explain the philosophy and approach we are taking with our Hacker Scouts Guild. First, we will be flipping the classroom, Sal Khan style. If you have not seen the TED video discussing this technique, I highly recommend you do so. I'll place a link to it at the end of this video and in the comments. Flipping the classroom essentially means that we will be doing all of the lecture portion through these tutorial videos at home. Then, when the scout comes to the hackerspace, we dive in with hands-on and implementing what they've learned. This frees the mentors up to provide more one-on-one support for the scout and maximizes the time they have using the tools available to them in the hackerspace. It also allows us to teach to mastery for every scout. During the video portion at home, the scout can take it at their own pace, rewind, pause, and not have to worry about another human there asking them if they get it. Did you get it? Did you get it? You understand? It also allows each scout to progress at their own speed once in the hackerspace as well. Since it doesn't matter how long it takes, each scout will achieve mastery before moving to the next step. It's basically flipped from a public school classroom in that the variable component to the education is time, and the fixed component is the expectation of mastery. In public school, if you don't achieve a mastery of a component of a course, the class moves on anyhow, as the fixed component is the timing of the curriculum. We at Hacker Scouts Guild 10 have a strong distaste for this teaching style. What I am doing now is preparing the header pins for soldering into the board. These pins are what make a Hackerling circuit a shield for the Arduino Uno. It's called a shield because it becomes mounted to the Uno via these pins, essentially covering it up, sort of like a shield. These header pins plug directly into the sockets already on the Uno, giving us an electrical connection to the power, ground, signals, and inputs and outputs to the Arduino microcontroller, as well as giving us a mechanical connection to keep the two boards stuck together. Of course, you can pull the two boards apart again and repurpose your Arduino Uno for some other purpose, should the need arise. They become temporarily mated together through these headers, and the Arduino provides life support to the shield, while the shield provides senses and the ability to interact with the outside world to the Arduino. After making sure everything lines up, I start soldering the headers into the board. If you watch closely, you will see something amazing happen before your eyes. While I'd like to claim that I lost 100 pounds in 20 years during the filming of this video, what is actually happening is that my oldest son, who is 16, is taking over from me on the soldering. Prior to this video, he had never soldered anything on a PCB, printed circuit board. This should give you an idea at just how quickly these scouts pick this up given the right tools and training. My son is literally learning to solder in front of your eyes, sped up 3 times normal speed for brevity, of course. Now it's Jack's turn. He's been watching me, and we've been discussing what he needs to know. Son, I do believe you've got it. Congratulations. Nice work, buddy. Let's move on to the resistor. Once again, small hands enter the screen. But they are not the same small hands. These belong to my youngest son, Max, who is 12. Again, you are witnessing a child learn to solder in front of your eyes. He then trims the leads off after soldering, and we are moving on. Next up, switch. This switch happens to be a DPDT, or double pull, double throw. It has 3 distinct positions. We will be programming the Arduino to watch the position the switch is in and do something based on that switch. What it is depends on your imagination. A little help with the technique Max is using helps us get this in place. Because it is a large part with metal surfaces, it is more of a heat sink than a little resistor. This means we have to preheat the leads more and make sure we have excellent contact between the iron and the part. Next up, IR receiver. This part is used as an input to the microcontroller. You could point your TV remote at it, another Hackerling with an IR emitter so that they could talk wirelessly to each other, or you could use it as the sensor in an IR tripwire, for example, to alert you anytime someone comes into your room. That could then trigger your Hackerling to announce they are being monitored and you are about to enable lasers if the intruder does not cease and desist. Whatever, you get the idea. Jack is now soldering in 2 resistor arrays. We discussed these in depth in the Hackerling tutorial series videos, but essentially, resistors act on electricity like a kink in a hose works in an outdoor hose. Kink it hard and almost no water comes out. Kink it a little and it just restricts some flow. They are also known as passive components, and they are one of the most simple parts of this project. You'll learn an awful lot about them. Moving on, we are installing 4 tactile switches. They are essentially push buttons, switches with springs built in to return them to open once the operator removes their finger. These are not to be confused with tactical switches, used for killing zombies by way of your Xbox controller. These 4 switches also provide input to the microcontroller. They can be programmed to allow for your Arduino to act in many different ways based on their input. For example, you could make a memory game like Simon. Wait, I'll bet you kids don't even know what Simon is. Well, that's what Google's for. Next, I put in some more headers. They act as pins that are accessible to be used to expand the abilities of the Hackerling beyond what is mounted to it. For example, you could output audio to a headphone or stereo, output stepper motor control to provide locomotion to a robot, whatever. You just have to dream it up and calm down and code on, dude. Now we have dip switches and an LED array. DIP stands for Dual Inline Package, and it is a tiny 4-switch package that can be used to set global setups for your Arduino. You're not going to use them as input like in the Simon switches on a regular basis, but if you want to make a change that is likely to stay made, these are your guides to do it. For example, you may have installed your motors backwards and you want to tell your Arduino that front is back and back is front. It'll make more sense when you actually do it, trust me. The LED array is just 10 LEDs that are placed in a bar that allows you to do cool displays. Use it as a bar graph to visually display temperature, sound levels, battery voltage, whatever you can measure. Next, we add a couple of IR emitters. These will be the mouth part of the conversation, where the IR receiver we added earlier will be the ears part. They are a special kind of LED that produces light in a spectrum below what the human eye can see. You may be saying to yourself right now, wow, this is easy. I'll get mine done in an hour. While I agree with the first part, it is easy. I will go on to be the heavy and caution you against racing through this. Don't forget, we're teaching to mastery here. You need to know everything about this circuit when you are done. Bottom line, you will be at it for more than an hour, no doubt about that. Now I'm doing some test fitting of the LCD and making sure everything underneath is happy and there are no clearance issues. As you can imagine, once that LCD goes off, the stuff underneath gets buried alive for eternity. Best to make sure you have it all correct now. Thanks for watching my overview on the Hackerling build. I hope it answered your questions about what we're doing and why. Roger Eddy, Guild 10 leader, signing off until the next video. We really hope you'll join us both online and at the UControl Hackerspace.